Hello again, Math 1343, Machine Shop Math fans. The intention for this video, which is going to be titled Video 6, is a review for the first exam, EXAM1, and there will be new information in here. We are not going to spend a lot of time on fractions again. We have beat this up enough. All right, so we know if we're going to add them, we have to have a common denominator. The easiest thing to do is to multiply the two denominators, come up with 15. What we do on the bottom, we have to do on the top. And so it's 5 times 3 and 1 times 5. Now, we've got many videos on this. I am not going to go through here. I will give you a word of caution. These things here in red, see this? This was my screw up when I first did this. I went back and rechecked my work, and I misread the decimal place. So even though this would have been, it's wrong because the decimal's in the wrong place. So y'all be careful in that regards. Okay. All right. We talked about negative numbers. If your answer has a negative and it is not in your answer, it is wrong. I don't care how good you are and how smart your mommy told you you were. All right? So if it's a negative, it better be in front. All your answers will have a fraction, and it'll have a decimal equivalent. If I have to take my calculator and convert your fraction, assuming it doesn't look like mine, into the decimal equivalent, I'm going to take points off. You've been warned enough. That's it. I don't care. Okay. Now, on a mixed number, all you got to do is divide 2 by 15 and then add it to the whole number. Okay. Actually, you can start with this. Okay. 32/15, divide that. You're going to get 2 and a third, or 2/15, which would be like 1/5. No, it wouldn't be. Forget what I just said. Just divide that bloody number and you'll end up with 2.1333. So the answer to your test could be this, and then 2. Let me get my pen out. Oh my God. 2 point. How about 2.1333. And it could be that too. So, I'm pretty much multilingual. That would be a dot, a decimal. Man, I'm screwing this up, aren't I? Yeah, let's erase this. There we go. Okay. You know how to do this. We've already talked about that. We've got 7/16 plus 3 and 1/8. So we still need a common denominator. So 8 times 3 is 24 plus 1 is 25. Okay. All right. All right. Let's go down to the next one. All right. PEMDAS. This is an example of me really screwing up. So I had to go back and fix it in red. PEMDAS, please excuse my dear Aunt Sally. That's parentheses, exponent, multiplication, division, plus and minus, addition, subtraction. The implied parentheses are here, right? Just do it and be done with it. Watch your math. I have no idea how I came up with this original number, but I did, and I fixed it. So 2 times 6 is 18. 2 times 6 is 12. See, I did that. I did it again. 2 times 6 is 12 plus 1 is 13. Divided by 3/4. Okay. So it's 13 over 2. It's not 19. It's 13 over 2. Watch your math. Yeah, screw that up. So I changed that number to... See, it's easy to do. Everybody makes mistakes. So, and again, we come down here and we end up with a fraction and a decimal equivalent. So just take this big number, divide 48 into it, and there's your decimal equivalent. Because the first thing I'm looking at is the decimal equivalent. I don't really care if your fraction looks like mine. You may have approached your fraction differently. You may have a different common denominator. I don't know, but when I divide these two, it better be my number, this decimal equivalent, or it's wrong. All right, and you will show all your work. Like I showed mine. That way I was able to go back and figure out where I screwed up. And again, everybody screws up. You need to learn to fail and not get all freaked out over it. All right, we're going to divide 7/9 by 1/4. You know how to do that. You flip this upside down and multiply it to the numerator. So now that is 4 times 7 and 1 times 9. That's a no-brainer. Okay, let's go down to the next one. This is what your test is going to look like. Again, we have, there it is. Again, we have a mixed number. I must have woke up when I did this one. So, we'll have 8 times 6 is 48 plus 7. That gives us 55. 8s down here. You see this? 55 8s. All right, we got 4 times 3 is 12 plus 3 is 15. We got 6. We got 16 times 6 is 96 plus 15 is 111. So it's 111 sixteenths. And then 8 times 2 is 16 plus 1 is 17. So that's 17 eighths. So here's our 17 eighths. And we know we're going to divide this by that. So we flip it upside down. So now that is 16 times 15 and 4 times 111. Now we have this minus this, and they're the same denominator. So we're going to go and do these two things first. So I went ahead and subtracted 17 eighths from 55 eighths. And then that gives us that. So what is this? Well, here we go. So this gives us 38 eighths plus 240 over 44. Do the common denominator thing. And now here's an example of getting to a lower common denominator. I kept dividing 240 by 2, right? These are even numbers, so a factor of 2. So this is 240 over 44. Divide that by 2, so that's 120 over 222. Divided by 2 again, that gave us 60 over 111. So I use this 8 times 111 as our common denominator, which is 888. So multiply 8 times 111, 111 times 38, and that gives us 4,218, plus the 8 times 60, which is 480. I added those together, and that was 4,698 divided by 888, and that's the decimal equivalent. Now, what's this decimal equivalent up here? What is this? Why did I do that up there? Because I cheated. I got a decimal equivalent here, which is 4.75. I got a decimal equivalent there, and then I added those two, and I came up with that. Just a way of checking your work. All right, there's so many different ways to skin this cat. There's an old Tibetan proverb saying there are many fingers reaching for the moon. There's also an old Tibetan proverb that people only are like the full moon. They only show you their bright side, and they hide their darkness. All right, here is a problem. You will see this again. You will see this again. You will see this again. We have a 20-inch long bar. It started out as 20 inches. Each cut in the bar eats up 1/8 of an inch. typical. So every time we make a cut, we lose an eighth of an inch. Each time we make a cut, we lose an eighth of an inch. That's a lot of material. All right, the first cut's 3.5 inches. The next cut is 3 1/16. The next piece is 3 3/4. The next piece is 4 5/16. And the next piece is 3 1/8. And like I said, there's a cut. So every cut is an eighth of an inch. So how many cuts do we have? We got 1, 2, 3, 4, 5 cuts. So that's 5 cuts. There's 5 cuts. 5 cuts at 1/8 inch each equals 5/8 of an inch. Now if we look up here, we'll see we got some 16ths for our common denominator, for our lowest denominator. So we're going to use 16 as our common denominator. We're going to use 16 as our common denominator. We're going to use 16 as our common denominator. All right. And I'm going to take these mixed numbers and I'm going to turn them into improper fractions. So, so 8/16. This is what we're going to do. What's a half? A half is 8/16, right? So this turns out to be what? 3 8/16. That's already in 16, so I don't have to worry about it. What is 3/4? 3/4 is 12/16. So this is also 3 12/16. This is already in 16, so I don't have to worry about it. This is 3 1/8. So that's 2/16 is an 8. So this one's going to be 3 2/16, right? 1/8 is the same as 2/16. So we got to figure out what's left over. So we could go through and add, since we're adding in this one, a little trick here we can do. We can go from the left all the way to the right, adding up the whole numbers. Because we're adding. We're not going to subtract. We're not going to multiply. We're not going to divide, right? We already know we have 5/8, or since we're going to be speaking in 16ths, 5/8 is 10/16, right? 2 times 8 is 16. 2 times 5 is 10. Okay. Now, let's add up the whole numbers. So 3 and 3 is 6, and 3 is 9. 9 and 4 is what? 13. And then 3 is 16. So there's our whole numbers. Now let's add up all the 16ths. So you got 8 and 1 is 9. That's 12. 12 and 15 used to be 27. Let's see. 27. Did I miss something here? I think I missed something. We'll do it again. 8. It's 9. And oh, there we go. Yeah. 8/16 plus 1/16. It's easier to do this with calculator. It's 9 plus 12 is 21 plus 15. That's where I screwed up. Man, it's early in the morning. 8 and 1 is 9, and 12 is 21 plus 15 is 36. Yes, 36. Plus 2/16 gives us 38/16. Y'all better be writing these down and using a calculator. I'm taking a shortcut. Now, don't forget your cuts. Your cuts are 10/16, right? So we got 10 plus 38. So we got 16 whole numbers. 16 is a whole number. We got 48/16, right? 38 and 10. So if you divide 16 into 48, that's 3 inches, right? So 3 plus 16 is 19. 19 minus 20 leaves you what's left over. We got a 1 inch drop. 1 inch drop. The drop is 1 inch. Take 19 from 20, and your drop equals 1 inch. Okay. That's how we do that. All right, so that's enough for fractions. We're not going to go back through this. You've got plenty of videos, plenty of that. We're already at 15 minutes. Okay. We may bust this one up into 2 videos. I don't know. I don't know. All right. Okay. There are 2 types of relationships. There's an indirect relationship and a direct relationship. Indirect and direct. Pulleys and gears. Pulleys and gears are indirect relationships. Pulleys and gears are indirect relationships. All you need to do is remember that. That's all you got to do. Just remember that pulleys and gears are indirect relationship. Now we'll talk about another kind of relationship in a minute. But pulleys and gears are indirect relationships. Now, right here, you're being introduced to your first equation. Your first equation, right here. Okay? This right here. The drive over the driven. The drive over the driven. Drive over the driven equals n of the driven and n of the drive. Now, anytime you see an equation, you need to look for the where n equals the speed in RPM. So we're looking, and we really should say D equals the size of the pulley, the size. Still not used to drawing with this tablet. Size in inches. Got to have units of measure. Units of measure is RPM, revolutions per minute, and the size of D is in inches. Okay. Our first equation. The equal sign, if it has an equal sign in it, then it is some form of algebra. Just get over it. The equal sign lets us cross multiply. It's a very powerful tool. Lets us cross multiply. Okay? Lets us cross multiply. Now I'm going to come over here to the scratch pad. So we'll probably need a marker. Tell this thing to wake the hell up. We'll use black. We're going to say D driven or drive over the driven. Equals speed of the drive over the speed of the driven. Now, in an indirect relationship, this belongs to that. Oh, what the hell? Why is this not working out? There we go. And that belongs to that. Now, we've got a lot of stuff in here. Drive driven, speed of the driven, speed of the drive. This is getting all goobered up. Well, let's change these. We can change these. We're going to call this A. We're going to call this B. We're going to call this N of B. We're going to call this the N of A. In other words, we have A. It's got the motor hooked to it, and it drives B. And it drives B. There's a belt around it, right? Okay. So we still don't know anything, so we can rewrite this. It's A B. It's simple algebra. Simple algebra. N speed of B, speed of A. Okay? Now, so we still got to have some value for this. Now, we have 4 variables. Each one of these little letter things is a variable. We got 1, 2, 3, 4. So you need to know 3 of these things out of the 4, or you can't solve the problem. All right, so let's just say that marker. Let's say A equals 12 inches. 12 inches. And B equals 4 inches. And we're going to solve for the speed of B. We don't know B. Excuse me. And we know the speed of A. We're going to say it's 1750 RPM. RPM. All right. So you got the size of the pulleys, or the shivs. Now, if we ask a question, what's the relationship of A to B? Then that's simply 12 over 4, right? 12 is A, 4 is B, and that equals a 3, 2, 1, right? 4 goes into 12 3 times, right? So it's a 3 to 1 relationship. 3 to 1, right? Now let's cross multiply. I guess we can do that in red. Let's cross multiply. So we're going to cross multiply to solve for B. We're going to multiply 12 times 1750, and we're going to multiply 4 times NB. And we get 12 times 1750 equals 4 times NB. Now, we want NB by itself, do we not? That's what we're solving for, is NB, the speed of B. So how do we do this? Well, we come over here, and we undo multiplication on this side. We've got to get NB by itself. So 4 times NB. So how do you undo multiplication? What's the reverse switch? It's division. So we're going to divide this side by 4. And what we do over here on this side of the equal sign, we have to do over here, right? That's what algebra means. Algebra from the Arabic, to fix the halves. This half equals that half. Okay. We got to do the same thing over here, so we're going to divide both sides by 4. So guess what happens? Magically, that goes away. And now we have this equation of NB equals 12 times 1750 divided by 4. Now, there's 2 ways you can do this. You can multiply 12 times 1750, and you can divide by the whole thing by 4. Or you can divide 4 into 12, and that gives you 3. And that would be 3 times 1750. So there's 2 ways to do this. So I'm going to divide 4 into 12, and that gives me 3 times 1750 RPMs. So that should be, what is that? What does that come out to be? Get your calculators out, do the math along with the video, and you should come up with, you should come up with, what should you come up with? You should come up with 5,250 RPM. Isn't that right? We'll double check it. 4 goes into 12 3 times, right? Divide by 4 equals 3 times 1750, and bingo, you get 5,250. 5,000, 5,250 RPM. Without the RPM, your answer is wrong. You understand me? Without the RPM, your answer is wrong. Okay. It could be 5,250 furlongs per fortnight, or widgets or something, but it's not. We're speaking in speed of RPM. So that's as simple as it gets. So cross multiplication in something as simple as this is a very powerful tool. It lets us solve for our unknown. Now, I'm going to go ahead and clear this out. We're going to go back to our review sheet. Oh my gosh. Like I said, I'm going to go clear this out. Now you know why I don't do cooking shows. Like the Julia Childs cooking show. Well, today we're going to do stuffed goose. I do have all her cookbooks. She was an excellent, excellent chef. Come home from school when I was young and turn on PBS here in Houston, Channel 8, and watch the Julia Childs cooking show. All right, we have all her cookbooks. Do you know that she was a member of the OSS as an operative during World War II? Yes, incredible lady. All right, so let's go back and look at our review sheet. Now, that was a simple deal. All right, in this case, we have A equals 12 inches in diameter, with N equals 1750 RPM. That means the speed of A is at 1750 RPM. 1750 RPM, right? Okay, now, we know the size of A, we know the size of B, we know the speed of A. A has the motor hook to it. Therefore, we only have one unknown. We can solve this with cross multiplication. It's really, really easy. So that's what we're going to do. So the first step is to set up your relationship. This is the relationship. Now, if I asked you what's the relationship of B to A, then it would be 4 over 12. But the relationship of A to B is 12 over 4. So just answer the question and don't overthink it. Second step is to multiply, cross multiply. So we have B times NB, we did this, equals A times NA. We got to get NB by itself, so we're going to divide the B out on this side to leave NB, the speed of B, by itself. What we do over here, we have to do over here. What we do to one side, we do to the other. And what do we end up getting? Okay, we divided that out. The fourth step is NB is this. We plug in our values now. Don't do the math until you get the equation set up. This is just simple. Follow the steps. So NB equals 12 times 1750 divided by 4. See, this is A. That's the size of B. That's the speed of A. And there's no reason why you can't do it like this. And this is what I do to keep myself straight. And we end up with that answer. Isn't that simple? That is simple. It's as simple as it gets. Play this video back over and over again. Follow the steps, the bouncing ball. You should not have a problem. Gears are also in direct relationships. Gears are also in direct relationships. Gears are also in direct relationships. We do not use the size of the gear because there are a plethora of formulas for doing gears. Gears all have to be of the same pitch. That's with a P. Just like a screw and a bolt and a nut have to be of the same pitch, same thread type, and the same thread dimensions, or they won't fit in. So, but it's the same relationship. It's A to B. The difference with gears is we talk about teeth. So in In belt pulleys, we talk about the diameter of the pulley. In gearing, we talk about the number of teeth. Okay? So in this case, we still have A is driving B. A has the motor hooked to it, or is driving B. Whether it has the motor or something else is turning A is driving B. All right. So you got A, the driven, A, the drive, B, the driven. The speed of B belongs to that. Speed of A belongs to this because it's indirect. We go through the same process. We still come up with the same equation relationship. NB equals A times the speed of A divided by B. Now, it's time to fill in the data. We've got it arranged the way we want. The next step is to fill the data in like we did with the one before. That's 30 teeth times 1750 divided by 15. Now, you could divide 15 into 30, and that would give you what? 2. And then 2 times 1750 gives you 3,500 RPM. This is your answer. With the RPM on it, or your answer is wrong. Now, what about multiple sets? Multiple sets of pulleys and gears. You do them the same way. You got to figure out which is driving which. A in this case is hooked to B with a pulley, right? A belt. Yes. A drives B. A drives B. B and C are hooked to the same shaft. That means whatever the speed of B is the speed of C. Now, about half the class always gets this screwed up because they don't believe me, and they get it wrong. And I don't care if you believe me or not. B and C are on the same shaft. They're either on the same shaft or they're a step pulley. So if B is traveling 100 RPM, C has to be spinning at 100 RPM. There's no bearing on the size of these two things. All right? All right, so we go back. Make sure we have enough data to do this. A to B is 12 to 6, right? Because we said A is 12, B is 6. All right. A is traveling. The motor's spinning it at 1750 RPM. So we have this. We have that. We have that. And C, we have the size of C, and we have the size of D. So great. All right. So we need to figure out the speed of B. Speed of B. Done this before. And guess what? Whatever the speed of B is also the speed of C. So when you solve this, if you get it right, you already have the speed of C, which in the relationship of C to D, see, I'm being a nice guy. These are all 2-to-1 relationships, right? C is now driving D. B is not driving D. B is hooked to C. B and C spin at the same RPM. Some of y'all are going to screw this up, man. I have no pity on you. I've told you this several times. A drives B. B and C are on the same shaft. Therefore, B and C must have the same RPM. Now, so the last one will tell you this. C drives D. So the first thing we do is we set the relationship up. A over B equals B over the speed of B over the speed of A. Now, we don't know the speed of B. We're going to solve for that. Your second step is to put C over D equals the speed of D divided by the speed of C, which happens to be the speed of B. Well, I just said I wasn't going to say it again, but I did. Merry Christmas. Okay? All right. If y'all don't get this is the simplest thing on a planet. All right. Plus, you got a video you can play over again. So it's not like you're sitting in a face-to-face class. You can nod off and go to Never Never Land. I have to wake you up. All right, so the first thing we're going to do is cross multiply, right? We got an equal sign between your most powerful tool on the planet. Well, with the exception of trig and a right triangle. So we cross multiply, bingo, bang. And then that cross multiplies to that. We solve for the unknown, which is that. We don't know what that is. So we have 6 inches, which is B, times the speed of B, we have A, which is 12 inches, times the speed of A, NA, right? That's a dot, not a minus, okay? And why am I using dots for multiplication instead of x? Because x is a variable. We don't want to get confused, right? All right. So we already know what we're going to do. We're going to have to divide out the size, divide, right? We did this before. We got to get rid of the 6 on this side. You got B, so we divide this side by 6. Remember, we did that before. Divide this side by 6, and you end up with NB equals 12. Play the video back. Okay. All right. Play the video back. Remember, we divide both sides by 6. All right. 6 will cancel out on this side. 6 is over here. 6 goes into 12 2 times. 2 times 1750 is 3,500 RPM, and that's the speed of B, which also is the speed of C. All right. Now you plug this data back in. You take this speed of C, plug it in right here for the speed of C. This is C. This is NC. It's also, which equals NB. And you do the same thing again. You cross multiply. You get 4 inches times the speed of D equals 8 times 3,500, which is the speed of A. So this is A. This is the speed of A. And this is B, and that's the speed. I mean, this is D. God almighty, I screwed this up. That's C, 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 and speed of C, which is speed of B, which is also speed of B. Remember? C, D, speed of D, speed of C. So, get that out of your head what I just said here. Okay, we're back. I was back up here. All right, follow the directions. Divide this side by 4, divide this side by 4, you end up with speed of D equals 8 times 3,500 RPMs divided by 4. 4 goes into 8 2 times. 2 times 3,500 is 7,000 RPM. Or you can multiply 8 times 3,500 and then divide by 4. You're still going to end up with this. All right, gears are the same way. If you have multiple sets of gears, you got to figure out which is the drive, which is the driven, which is hooked to the same shaft, blah, 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 blah. All right. So, gears. You got gear A, which drives gear B. Gear B and gear C are stuck together. They're either stuck together because they're made together, they're hobbed together, or they're on the same shaft. So whatever B spins at RPM-wise, C spins at the same RPM, and then C drives D. So in this case, A equals a 20-tooth gear, B equals a 10-tooth gear, C equals a 40-tooth gear, and D equals a 30-tooth gear. B and C are on the same shaft, therefore they have the same RPM. Do we have the initial input speed of A? Yes, we do at 1750 RPM. So guess what? The relationship of A to B is 20 over 10. If I asked the relationship of B to A, it would just be the inverse of this, 10 to 20. But we're asking for A to B, just 20 teeth over 10 teeth. The relationship of C to D is 40 teeth over 30. You set it up the same way. A over B equals the speed of B over the speed of A. Cross multiply. You know how to do the division. You're going to divide 10 off of this side. You're going to divide 10 from this side. And you end up with what? 10 into 20 goes 2 times 1750. So the speed of B is 3,500 RPM. If the speed of B is 3,500 RPM, the speed of C is 3,500 RPM. Yes? Yes, it is. So then you take the answer for the speed of C, because it's the same as the speed of B, assuming you did your math right, and you plug it in the relationship of C to D. So that's 40 over 30 equals ND, the speed of D, over 3,500 RPM, the speed of C. You're going to cross multiply, cross multiply, cross multiply. And you would have ended up getting what? 30 times D, right? So we're going to divide this side by 30. And we're going to divide this side by 30, right? Just like we did in the previous one. Now, I didn't do that. I took a shortcut. But in reality, you know that this is 30 times ND equals 40 times 3,500, which is the speed of C, right? That was this NC. And this was C. And this is D. So we want ND, the speed of D, so we're going to divide this side by 30, divide this side by 30, right? 30s go away, they disappear, leaving us ND equals 40 teeth times 3,500 over 30. Now you can divide 30 into 40 and then multiply times 3,500, or you can multiply 40 times 3,500 divided by 30. I don't care. You're going to end up with 4,666.666667 RPM. Yeah, 666, the number my ex-wife thinks tattooed on the back of my head. And that's it. That's it for the indirect relationships. I screwed up. I did. See, pulleys and gears are indirect relationship. So that ends indirect relationships. Now this particular video has gotten to be about 41 minutes. What we will pick up in the part 2 of this video will be tapers and direct relationships. Tapers are direct relationships. So we'll do part 2 momentarily, and we will end this video. This will be part 1 of your exam, which is video 6, which is exam 1, part 1. Any questions, play it back, or you can email me. But if you email me a question that's obviously in the video, I'm going to tell you to go rewatch the video. So that ends part 1 of video 6.